Greetings everyone, and welcome to yet another session of revision of organic chemistry. In the past two videos we handled KCSE 2021 and KCSE 2020. So in this video we're going to go to KCSE 2019, and in this case the organic chemistry questions was featured in paper 2, number 1. So very fast you can go to the question. Part A, alkanes are said to be saturated hydrocarbons. What is meant by saturated hydrocarbons? First, a hydrocarbon is a compound that contains hydrogen and carbon. And part 2, saturated has a maximum number of hydrogens, or the carbon-carbon bonds are single covalent bonds. So we can write the compounds made of carbon and hydrogen only, compounds made of carbon and hydrogen only, and where carbon-carbon bonds are single covalent bonds. Part 2, draw the structure of the third member of the alkane homologous series and name it. An alkane has a general formula of CnH2n plus 2. The third member where n is 3, so we'll have C3H6 plus 2, 8, and in this case it's called a propane. So just note that you have n as 3 and you have general formula CnH2n plus 2. Let's go to another part. When the alkane hexane is heated to high temperature, one of the products is ethane. This should be ethene. Write the equation for the reaction. First, you should note that it's a cracking reaction where you heat and crack a long chain alkane to form an alkene and a shorter chain alkene. So we are starting with hexane C6H14. We are undergoing heating to form ethene. So C2H4 is an alkene plus a shorter form alkane. The difference between the 6 and 2. So this is C4H10. Another way you can do this, you can just write C6H14. If you crack it through heating, you can form again ethene C2H4 plus a shorter version of the alkane C3H6, an alkene plus methane. All these two can be obtained through heating at high temperature, and this process is called cracking. Part 2, name the process described in B. Name the process. We already say this is called thermal cracking because temperature is involved, thermal cracking. Well, part C, study the flow chart in figure 1 and answer the question that follows. Before you go to the questions, you study the flow chart, answer all the questions that you can before attempting the question. So you can start anywhere in the flow chart. If we start at ethanol, we can go to ethanoic acid by a process called oxidation. It's important to just write the structure here. Ethanol is an alcohol with an OH. Alcohols undergo several reactions. One of the reaction is oxidation. The common oxidizing agent, which is very commonly used, is a strong one, potassium permanganate, in the presence of acid, acidified potassium permanganate to form ethanoic acid. Ethanoic acid is CH3COOH. Ethanol undergoes a process of dehydration where you lose a water molecule and you form an alkene with the 2 carbons. So it's C double bond C, and then this one is just 2 hydrogen. And this process is common dehydration of alcohol, and the common dehydrating agent is concentrated sulfuric acid and heating. Part A goes to D through a process called polymerization, forming a polymer. So D is a polymer, and the reagent is, this is ethene because of 2 carbons. So this is called polyethene, normally called polyethene. These are the papers that we see. So let's go to another process. Ethanoic acid is warm heated with ethanol and forms B. So this is a process where you react alkanoic acid with alcohols to form ester. So this process is called esterification. Ethanoic acid, the form is this. Ethanol is CH3CH2OH. So this B is going to be an ester from an alcohol, and this. So this ester is going to be CH3COOCH2CH3. So you can name as ethyl ethanoate. Let's go to the last part. Ethanoic acid is reacted to dilute sodium hydroxide. So this is an acid, this is a base, so this is a neutralization reaction. You're going to form a salt. So this is called sodium ethanoate. So you can just write CH3COO and then N, because this is the only hydrogen that is replaced when you react sodium hydroxide with this one, this hydrogen, and this will form water, and sodium will attach here, this part here. So let's go to the questions. Identify A. We have already said A is a dehydration product between ethanol and a strong dehydrating agent. So you get an alkene. So this is ethene. So we have already seen there. Okay, we can say this ethene, or we can just say C2H4. State one physical property of B. One physical property of B. B is ester. Ester are usually pleasant smelling compounds. Fruity, pleasant smelling. You can just say pleasant smelling compounds. They're usually miscible in water, and mostly they are colorless liquids. Part 3, draw the structure of D. D is a polymer from the monomer ethene. So this is a polymerization reaction. So this is a general formula of a polymer of ethene. So this is simple, just write where the number of monomer could be as many as possible. Part 4, give a reason why D pollutes the environment. D is a polymer. Synthetic polymers, number 1, they are non-biodegradable. They don't decompose. Non-biodegradable, so they do not decompose. Number 2, when burnt, they produce toxins. And number 3, they accelerate fires because they are flammable. Accelerate fires because they are flammable. Part 5, write an equation for the formation of F. So what is F? F is a sodium salt of ethanoic acid. So ethanoic acid is CH3COOH plus dilute sodium hydroxide. So you say this one and this one will form water, and this one will just join to replace the hydrogen. So CH3COO, sodium plus water. Part D, describe an experiment which can be used to distinguish butene from butanol. Butene is an alkene, butanol is an alcohol. You have to identify a reaction that is not common to both. First, you need to know alkenes undergo addition reaction, alcohols do not undergo addition reaction. Number 2, the common reaction for alkene that differentiates from alkanes and alcohols is the decolorization of bromine water. Bromine water is colored, is yellow or brown. So if you bubble an alkene or you put an alkene in bromine water, after some time it decolorizes. While in the alcohol, there will be no reaction because it does not react with bromine water. So you can just say, add separately bromine water, add separately to butene and to butanol. And then you'll observe that brown-yellow color of bromine water persists. Brown or yellow color of bromine water persists in butanol, but will be decolorized in butene. Good. So let's go to the final part. You can burn butene because it's unsaturated. It burns with a sooty flame, while butanol, it has a blue flame. Well, that's it for KCSE 2019. Don't forget to subscribe for more videos and leave your comment in areas that you need more emphasis. And thank you for your time.